Hello, IPX. We are at Embedded World 2024. Now, we talk about disruptive technology every day. You know that. We talk about semiconductors, disruptive semiconductors every day. But what goes on to make a disruptive semiconductor? Well, we're on Cadence's booth, Embedded World. If you like, that's the engine underneath the bonnet. These are the clever people that make it possible to make all the chips that you then go and turn into amazing projects.
Okay, so here is basically a partner that's built a SoC and a chip and a platform that's trying to demonstrate how Edge AI is making an impact into our daily lives. So you've heard a lot about image classification or object detection and so on and so forth.
Yep.
Now the new world is all about large language models.
Yep.
And what's called LLMs. And these days you also hear about both image and text being fused together in a fashion which is called large image models, called LIM.
Right.
So this is state-of-the-art
image
model. Yes. And so there are visual models and text models all fused together to work together to make both text prompts and image do inferencing on the edge, which is unheard of, cutting edge, as best as it gets.
Okay, so we talk a lot about AI
Yep.
at ipxchange,
Uh-huh.
and everyone will tell us we have AI.
Yep.
And when you actually unpeel it
Uh-huh.
and you ask them
Uh-huh.
what bit of it is AI,
Uh-huh.
they don't actually have an answer.
Right?
They have very, very clever spreadsheets
Yeah.
that are processing very quickly.
Yeah.
They don't have what you're describing.
For sure. Yeah.
So this is a really good example where we might actually see real AI in action.
Yep.
And it's a fun demo. So show us the demo. But before you do that, just tell us a little bit about what's actually going on in there.
For sure, yeah. Of course. So like I said, there are multiple pieces of this thing here. The first lowest piece essentially is what is called as IPs, which are like intellectual properties or hardware or code that runs basically to build an SoC or a chip, a system on chip.
Yeah.
So what happens is that people take our IPs, that's where Cadence Tensilica comes into play,
Yeah.
because they want to get time to market,
Yeah.
not have to build everything themselves. They
Yeah.
build all these things together, make a chip, make a platform, and then create this hardware here that basically they would white label or sell it
Yeah.
to other customers or OEMs, if I may.
Yeah.
Okay.
Yeah.
So here it is basically when you unpeel it, underneath the hood, there's basically DSPs, digital signal processing, and AI acceleration actually happening on the edge, not on the cloud. That's
Yeah.
actually happening on the edge.
Yeah. So none of this is connected to the cloud at all.
Not at all.
It's not using big data centers to
Nope.
do all of this.
Nope.
This is actually taking place in the device.
Yes.
And none of that would be possible without the libraries that Cadence delivered to the semiconductor manufacturer
Absolutely.
in order to do that large language model. And what was the other phrase you used?
Large image models.
Large image models. Right, so show us what's going on.
Okay, so here's the demo here. So for example, here's a camera that's actually taking live pictures.
Yep.
And these live pictures are basically being fed into the signal processing and the AI acceleration all happening inside the edge without any inferencing happening on the cloud, like you correctly mentioned.
Yep.
So this is a prime example where you basically need to run AI inferencing workloads, which are obviously big workloads,
Yeah.
on the edge at very low power.
Yes.
Otherwise, these things won't exist.
Yeah, yeah. So just tell me, how does Cadence go about not just the inference, not just the modeling? How does it go about solving that low power model?
Okay, so what it does basically is that what we do fundamentally is that we design IPs, right?
Yep.
And at the heart of the IP essentially is for us to understand how these models can run efficiently on our hardware. Obviously, hardware is one aspect, but the other aspect is software. So both hardware and software have to work together to be able to run these workloads. So what we provide is not only the hardware, but actually also provide the compilers, the tool chains, and libraries that have been very well optimized to run these individual networks and models on the edge, which would not have been possible without us intervening and giving a whole solution which engulfs both hardware and software.
Right, right. So show us what the demo actually does.
Fair point. So I got a bunch of text prompts here that I've written down. Obviously you can write more to it, but For example, I have something like a Coke bottle, and I'm putting right this in front of this thing, and I've given it a prompt.
So all of this is being done. All of this is being done absolutely real time.
Real time.
None of it. We haven't practiced any of this at all.
Not at all.
This is just what's going on.
It's impromptu at best.
Yep.
So I put some things here like a Levi or a Cadence, whatever hat, whatever you want to do, and I'm just putting some objects in front of it. So think about if you're, so let's say you have a conveyor belt,
Yep.
and things just rolling over on the conveyor belt,
Yep.
and you want to look at something which is suspicious or what have you, or malicious, whatever be the case, you just type the prompt and let this image being captured and tell you what is the
Yep.
probability of that thing being seen in that image at real time, live, without you having to interpret the data yourself.
Right. So that is truly AI.
Edge AI,
That is actually Edge AI,
that's correct.
because it doesn't necessarily know what everything is coming.
Yes.
And it's identifying it when it comes along.
Absolutely correct.
Right.
So as you can see, I put some Coke bottle here, figure it out. I'm going to swap it out with something else. For example, something as small as a candy thing, and you can see, right? It figures it out. Essentially.
Right. So let's just show the audience what's going on there.
Yeah, exactly. So for example, here what's happening is I put a mouse in front of it,
Yep.
live in front of you, and essentially what's happening is I gave a prompt to the mouse, and what it's doing is looking at the image and looking for all these prompts and telling you amongst all these prompts what is the probability of the top 5 that I see in this image.
Okay. Yeah.
Okay. Now, obviously, some object could have multiple classification labels.
Yep.
Something like a wallet might appear like a small mouse and a wallet at the same time.
Yep.
So it knows how to do all that stuff. But the point is looking at these prompts and the image and live captioning it and telling you what is the probability of finding these prompts top 5 inside this thing.
Right. So in terms of it actually learning, what's the definition, or how do you go about saying this is a mouse, this is what you're looking for?
Perfect.
What happens? How does that work?
Thank you. So that's a very important question. So I think that is where AI inferencing, or AI, essentially has two components. One is the learning component and the inferencing or the serving component. What we're
Yes.
showing you is the inferencing serving component. The component where essentially it learns is actually run basically in the cloud, where you essentially have to take lots of images, lots of text, label them, give them the ground truth for it to learn. And that's how the neural network actually learns. That's what's called AI.
Yeah.
It's artificial intelligence.
Yeah.
It's intelligence because you're providing it data labeled either supervised or unsupervised. It's learning, and once it's learned enough, that model is being served on the edge.
Right.
So
Right.
it's a combination of both learning in the cloud
Yep.
and then edge being the serving of the inference.
Right. So what's going on here is you've delivered to the semiconductor provider here.
Yes.
The library that enables it.
Yes.
To learn what something looks like.
Yes.
And then differentiate.
Yes.
Without any connection to the cloud.
Correct.
So you give it 5 definitions.
Yes.
To look at.
Yes.
And at any point, it's got the ability to recognize it, see it, and then give some kind of alert to say, this is what I found.
Absolutely correct. That's exactly what it is.
Right.
It's basically taking what's learned on the cloud and taking the model and then deploying this model.
So you link the two things together.
Yes.
Right,
Exactly.
right. So just remind us, what were those 2 phrases? Because obviously we know understand the learning models. We just talk us through those 2 different ways of doing it that you described.
Sure.
Again, just so that we're clear, so that
Sure.
people can understand what you actually said.
Sure. So typically what happens is that when you do inferencing or AI on the edge, it's actually 2 parts. One is essentially the learning part, and fundamentally the reason why it's called learning is because essentially what you're doing is you're providing it a whole bunch of data, lots of data, millions of data, gigabytes and petabytes of data for you to learn the model and adapt the model for that particular data set.
Yeah.
So you provide the data set and you create a model. That is very intensive and a very rigorous process, and that requires to be done on the cloud, because obviously you're talking about petabytes of data. Right?
Yeah.
Once the model has been created and you're happy with the model, then what you do essentially is you basically take the model and then go through the compiler tool chain to deploy the model on the edge. So the first aspect is learning from data. It's kind of like how your brain learns over time, and once it's learned, then you can obviously say, now that I know what a cat and a dog looks like, I can distinguish between a cat and a dog.
Yeah.
But the very fact is your neurons in your brain have to learn about a cat and dog.
Yeah.
It happens over time. That's pretty much what you're doing in this thing. You're learning, and then you're inferring.
Yeah. So learning inferring. So the key thing here for the audience
Yeah.
is to understand that as an embedded engineer,
Yeah,
you have this solution.
yeah,
There's chips in there
Yes.
that are doing this job,
yes,
doing all this learning, inference,
Yeah.
understanding,
yeah,
seeing that this is a mouse,
yeah,
seeing this is a biscuit,
yeah,
seeing that it's different,
yeah,
recognizing it on the screen,
yeah, absolutely.
and without cadence,
Yeah.
none of that would be possible.
No, I think this is learning on the edge is very tricky. It involves things which are very, very power sensitive, area sensitive. So that's a very different skill set. You need to have people with tremendous skills in both embedded software, embedded hardware, because you want to design the best in class IPs that you can then deploy, because you don't have in many cases, power consumption or things that you can afford in the cloud or memory.
Yeah.
Be very tightly constrained.
Yeah.
So embedded devices are very constrained. AI is actually pushing that umbrella to make it even more constrained.
Absolutely, and as we know, AI burns power and will continue to burn power
For sure.
like nobody's business. So I'm sure everybody's heard of the name of Cadence. We understand what Cadence do, but there's a real life example of where Cadence have got to be ahead of the game, understanding the learning model. How do you take AI? As you're embedded engineers, you're understanding that it's in this example, so we can understand that you will continue to be ahead of the game,
Yes.
understanding how you do AI at low power,
Yeah.
and give that kind of example.
Yeah, and I think none of this will be possible without an ecosystem by itself. So you need people like this, and I'll give a big shout out to LabForge, a company that is building all this stuff and doing all the training and doing all the hard work. We work with them closely. A big shout out to them for making this platform available for us. These are very strong partners. We've got a strong ecosystem that has both hardware, software, embedded, platform builders, all kinds of stuff. These kind of partners really make it our lives easier to deploy. And without them, we don't exist. They don't exist without us. It's a very mutual relationship, and that's how Edge AI will work forever.
Very good. Thank you very much.
Thank you.
Hey, yo, where my engineers at?